Everyone. Am I audible? Am I visible? Everything is perfectly okay.
Yep, everything sounds perfect. Yeah,
I
looks
would
perfect.
encourage more
Oh,
people to start
nice.
the camera.
Yeah, that would be good for me. At least I'll be able to see everyone.
Right.
Otherwise, it feels like I'm seeing myself and teaching.
That must be
Just,
scary, no?
yeah, it is scary. I'll just send a reminder on Discord. Okay, this is done. So, did you guys get the chance to try writing any socket server application? Anything you wrote?
We'll write it in the week because a bit short of time.
Mm-hmm.
But Amit, the one question, like I was asked in the interview, like
Yeah.
what exactly happens in bind, in listen, and in accept? Like they wanted me to know, like exactly when the buffer is created, when the port is like, what exactly happens is they asked. So when I tried to answer something, then they said that okay, then what happens in accept? When I tried to answer that, then they said okay, then what happens in like they tried to confuse me. This was long back. But if you can quickly answer before others join, sure. Yeah.
Exactly. If you say it will be like something like also library dependent, like something might happen differently on Windows and Linux both. But mostly it is like when you create a socket, a buffer and all is assigned by the OS for that particular socket, right? And then you do a bind and all operation. Bind, you are telling a socket to bind with this particular address. So anything that comes to this address and port is telling the OS that you have to associate with this socket buffers and all. So anything comes on this port and IP, you have to come to this buffer, which is associated with this socket. So in bind, if you see, you are associating a socket with the IP address and port, right? In listen, you are telling OS, "Okay, now I am ready to do everything. Now you can go." It is like telling I can passively, telling I'm passively ready, right? So I'm ready to do the operations now. So I'm ready to take the connections. So in except you are actually waiting to take the connection, right? So in except you are just waiting for the any particular connection to come into the except wala queue. The moment it comes, it will take out from the queue and it will start doing send and receive whatever you want to do. So this is how roughly it happens, right?
I mean, thanks for
Okay.
putting the
Any
document. Actually, like I enjoyed reading the details of each of the calls. No, send, receive. You put it very nicely. Okay.
yeah, I put it because I feel that is very important to understand
Yeah, yeah.
to write any server client code. So you should know what is happening behind the scenes, right? I'll give you a proper notes also. Like that was only for yesterday. So after I've finished Epoll and all, I'll give you a more notes, more code and all to try yourself, right? Okay. I think 15 people have joined. Should we wait for some more people or should we start? Anything you want to ask from yesterday's class, like before we start?
Sorry, Amit, I
Uh,
have one question. Not related to the yesterday class, it related to the multi-threading.
Mm.
Can I ask now?
Yeah, tell me.
Yeah, Amit, actually, I was in interview. I got a question that how the mutex is differ from the condition variable. I tried
Mm-hmm.
to explain say signaling thing that is a
Mm-hmm.
thread blocking thing, but
Mm-hmm.
they asked a question that in a multi-core system, does the condition variable have that significance over mutex? Does it
In a
important?
multi-core system.
Yes, yes.
Yeah, I mean, those two are serving different purposes only, actually. So mutex is like when you give a mutex, you are telling one thread to stop if some other thread has already taken a mutex. In condition variable, you are telling if something has happened, you want to notify it to other threads to like start up. So it's more of a signaling mechanism what we are trying to do in condition variables.
Yes, Amit, but in say in condition variable, we are getting an option, right? We are making the threads to sleep, not poll continuously. We will say that when
Mm-hmm.
it is ready. But in
Yes.
mutex, what happens is that it tries every time. it will try to unlock, but the lock is already acquired by another thread,
Hmm.
so it will go into sleep mode, right?
Hmm.
Here
Hmm.
it will wait mode until we signal it, right? That
Yes.
advantage
Yes.
we are getting, right? But they
Yes.
ask
Yes.
us
That
that
advantage.
in multi-core also you will get advantage or not. I was not able to answer that. I was not pretty sure on that.
Yeah, you will get the advantage in multi-core also. I mean, why it has to do with multi-core is what I'm thinking. Is it something has to do with multi-core? I mean, how is it related is what I'm thinking right now. So okay, let me check once to just to be sure that there is nothing, there is no catch behind it. I will also check it once
Yeah,
instead of
sure.
giving wrong answers.
Yeah. Thank you, Amit.
Yeah. Okay. Shall we start? So what we'll do today is we'll do a we'll try to write a proper code today, right? We'll do a proper folder structure. How we'll put our code, where to put our code, and how we'll make the folder structure in such a way that the code what we'll be writing will be portable. Like if we compile this on Linux or Windows, it should all compile, right? And then once we are done with this, once we have reached till the part we have done yesterday, like we have done till thread pool, right? After that we have done written all the code, then we'll move on to understanding how to use Epoll, right? So shall we start? So I'll be sharing my screen. Mm, yep. So you can see the screen, or
Yeah, yeah,
this is
yeah.
the
We can see
screen.
the screen.
So
Yeah.
this is the screen that we were checking yesterday, right? Yep. I'll put this here. Recording is started.
Yeah. I think right in the beginning.
Okay. Okay, so we'll start. So what we'll do here is we'll start from the very beginning. Okay. So I'm just uh, 1 second. Give me a second. Uh, okay. So what I'll do is I have my Linux box connected here, and I have connected it through my VS Code. But what I'll do is I'll just delete it, and I'll create a separate uh, networking. I should create. Okay. So what I'll do is I'll try to delete everything. Uh, I want to make everything fresh so that everyone sees how to start from the very basic, right? So I'm deleting this networking from here, and I'm deleting it from here. So everything is clean. Okay, it will take time. So I will create, let it delete. I think it will take time. So meanwhile, I will close this also, what we were using. Reconnect. Okay, this is deleted. So what I'll do is on Linux machine, this is right side is my Linux machine, left side is my local machine, right? So I am going to create a new directory. Let's call it networking only. I'm starting full fresh, right? So networking, and this side also I'll create a new folder, networking. Okay, and this one I'll open in my VS Code now. Let's see. Advanced CPP classes. No, this one. This one. So I created this networking folder. I'll directly go into this networking folders, CMD and port dot. So this will open my VS Code in that networking folder, right? So now here I will work. This is there. Okay. Discovery. So my networking folder is open. Yeah. And here you can see the other folder. So we'll be doing a lot of code today, right? So be communicative with me. Okay. Right. So yeah. Okay. Both side is done. my networking folder is open. So what I'll also do is I'll open this networking folder on my Linux system also. So I'll go to connect to host, my Ubuntu machine. So stop me if you don't understand anything. So this networking folder I've created on Linux right now. So that networking folder I'll open. Okay, so this is also set up. Now I have to create some files. So okay, so before I'm creating a file, what I'll do is I'll try to tell you how the folder structure is gonna look like. How I have tried to build. You can also try your own. Like I'm not saying that this is the perfect way to do it, but this is how I have planned. So inside the networking folder, I'll have a TCP client and TCP server, two different folders, right? So what I'll do is I'll start keep on going. So in here, inside this networking directly, I'll have two folders. One will be TCP server, and other will be TCP client. And each of these folders will self-sustain a static library. So each of these folders, so TCP client will create a static library for a client, and TCP server will create a static library for a server, so that any other like any third party can use this library to create TCP client or TCP server. That is how I'm planning, right? So this can be usable. So suppose I have a third folder, let's say in this examples, right? And each TCP clients, so on top, I will have a CMake list, which will be able to build everything together. So I don't have to build everything individually. So CMake lists dot txt. And inside this, each will have its own CMake lists. Oh, one sec. CMake lists dot txt. And similarly, TCP client CMake list.txt. Okay. And examples will also have its own CMake lists. Make lists.txt. Okay. Now, how will you plan is on the top, what we'll do is first we'll let me copy paste some boilerplate, what we always write. Okay. So let's copy this. Okay. So minimum version project, let's call it networking only. Networking, I am keeping it version 1. I'm using 14 standard. You can use 17 or anything. After that, what I will do is, if you remember, we'll have a lot of code. We'll have a lot of code that will be very specific to Linux, and some code that will be very specific to Windows, right? Because networking library is not same for both of them. So we'll have to use conditional compilations. If you remember, we did this in C while we were doing CMake, how to do conditional compilations. So what I'll do is I'll write this. Just let me know. Stop me if you don't understand anything. Okay, so what I'm doing is on the CMake, I'm detecting which platform, and I'm setting this platform name, which I can use it in my CMake, and then I'm adding these definitions. Remember this? If I add it like this I can use it in code, this platform in Windows or platform as to use it as a conditional compilation that I'll show you later. Is this clear? So if it is Windows, I am adding this dash D platform Windows. So in while in code, what we'll do is if define platform Windows, then we'll write some code. If define platform Linux, we'll write some code like that. So CMake will do what? Depending on what platform you are on, it will push this flags, right? Platform Windows or platform Linux and platform Mac. Correct? Clear?
So Amit,
Okay.
can't we use directly Win32 all the effects that
We
we have
can,
written?
we can, but I just want to put it like properly. Like when I'm coding, I'll want to look it like platform Windows platform. You can directly
Okay.
use Win32 also, no problem. Okay, this is how like real project they do, no? This properly they put it. Okay, this is what platform Mac, so that everything is on. It is like controllable from here on CMake only directly. Okay. So now after that, what we'll do is because we have three projects, right? So one examples, client and server. Example I have put so that this is like a third party user who will be using our libraries to create client or server, whatever. So this that will go inside examples. So what we'll do here is we will add all the subdirectories, right? So add subdirectory for server, add subdirectory for client, and add subdirectory for example. So TCP server, TCP client. I think this will help, right? When you will be writing a code properly, huh? And examples. Okay. So these three things are added. So now we have to go inside each of these CMake list, and we have to tell key what we have to build and all, right? Correct? Let me open the terminal also. Yeah. So let me go to the server, TCP server, and let's see. So inside TCP server, how I'm planning is see like this. Let me know if it makes sense. So inside TCP server, what I'll have is suppose one file. Let's call it what should we call TCP server.h, and let's call it TCP server.cpp. Fine. So what this two will be, it will be like a API to the outside world. So any person who wants to use our TCP server will be using actually the API that will give in TCP server.h, right? And then platform specific code will be inside these two folders. So suppose for Linux, I will put it like this. So Linux is like this. I will create three folders for Linux, Windows, and I'm putting it for Mac also. I'll not be writing code for Mac, but I'll tell you that how you can build it for Mac also, like what code you can put it in Mac. So I'm trying to make it like actual platform independent, right? I'll making it for Linux, Mac, and Windows, all three. If suppose in future you have a different set of OS that you want to support, you can just create a folder here and then do that, right? And because write specific code which is for that particular is in that particular folder. So inside each folder, I can have two files. I can have, let's call it lin.cpp and lin.h. Is it okay? Are you getting what I'm trying to do? So inside Mac, similarly, what we can have is mac.cpp and mac.h. And similarly for Windows, win.h and win.cpp. Okay. And so this will be the common code, and this will be the platform specific code inside each folder. Getting the point? So this will the code which will be used by the outside world, like the third party who will be using our libraries, will be actually using this TCP server, whatever we put the API we give. And this API think of it will be like a wrapper who will be like putting it out. Okay, this because you are on Mac, let me go to the Mac wala thing. And if you are on Windows, let me go to the Windows wala thing. And then call the actual APIs, right? Yeah. So it will be a socket library. So remember, right, for the socket, we don't have a pretty standard library for all the platforms. We'll have to write a platform specific code. That's why we are doing this. So we have done for this. So let me just do it for, we'll just make a folder for client quickly. So similarly for client, what we'll do is we'll have two thing TCP client.h and TCP client.cpp, right? And inside TCP client, we'll have three folders: win, and then lin, and mac, right? And similarly for each, we'll have two files: lin.cpp and lin.h. I'll just make these two quickly: mac.cpp, mac.h, Windows, win.h and win.cpp. Okay, done. And inside examples, we'll make two things, like we'll have one server and one client, right? So I'm just putting out two files. One will be like a server.cpp. So we'll be making two executables, one for the server, one for the client, right? So one I'm keeping it as server.cpp, another let me call it client.cpp, right? So now my folder structure is complete. So now let's go to each one of those. So this is client, examples, and server. Let me go to server first. So inside this TCP server CMake list, what will happen? So inside TCP server CMake lists, let's see. So what we'll do is, let me know if you understand this. I'll go through it line by line, okay? Copy this. Okay, so inside, see, right now we are trying to create the TCP server ka static library, right? So what we are doing is, this is TCP project I have written. So I'm checking if it is Win32, right? So I'm setting server OS source as win.cpp, right? If it is Unix, means it is this is for the Linux. So if it is on, you are on Linux, then my server OS source is lin.cpp, right? And if you are on Apple, my server OS, the source is mac.cpp. So when I'm creating the library, what I'm saying, to create the TCP server, what I have to do is I'm creating it as static, and I need two files to create this static library. One is the common TCP server.cpp, common one, and the other which is platform specific, which I have, which will come from here, like $server OS source. Are you getting this point? So how this library will be created? So how CMake will decide which source to take depending on which platform you are building for. Are we providing different implementation for whole server? Only snippets of the server will provide different implementation to support different OS. Rama, I didn't get the question. Okay. And target include directories, which include files we need. So for this TCP server, we are telling ki whatever the current source directory, no, you take it as the include. So this, but whole TCP server will be used as your include, include for the include files. These all should be okay, right? We have covered this in detail, how to use target include directories so that you can use directly hash include, and that lin slash that directly you can use. Is it fine? Or you have forgotten everything? Yes, no, come on. Tell me, otherwise I will have to go
Yeah.
slow. Yeah. Right. So is this fine? So you understand, right? We are creating a TCP server ka static library, which will be like a .lib or .a file. And how we are creating, which files do we need to create this static library? This is the one common file, TCP server.cpp, this one, and platform specific source file, which I am trying to include, trying to deduce from here. If you are on Windows, my file will be WinCpp or LinCpp or MacCpp, depending on the platform. Correct? So this is how my TCP server will be built. So similarly, if I try for the TCP client, what will be the code? I think now everyone can guess. So I'll just directly copy paste. So for TCP client, similar. So project is TCP client. Similarly, on Win32, I'm trying to deduce which CPP file I need, and add library as a static. I need this common file plus the client specific, right? Correct? This I will tell you why is it needed. On Windows, no, so this will be I don't think this will be required. Forget it. If it will be required, we'll do it at that time. So same as the TCP server, we are trying to build a TCP client library, right? So that others can use to create a TCP client. Is this clear? Shall we move ahead? Okay. So similarly, in examples, what we can do is
In TCP client CMake list,
hmm,
the first line which
mhm.
we generally use is missing, right? Minimum version required or something.
Why you can means ignore this writing, because I have already given this in the common, the
Okay.
upper one. So it will take it from there.
Okay.
So that is fine, right?
Yeah.
Okay, so for examples, what I can give is this. So suppose my project could be demo I have written. CMake standard is this. So see, I'm saying I'm creating two executables. One is add executable I'm doing, one I'm creating server with which source file server.cpp. Remember, I will be creating two executables. One server will be created using server.cpp, and what target I'm linking for this server? TCP server. Remember, I'm creating a TCP server library. So that library I'm trying to link for this particular executable when I'm creating the server. And then similarly include server directories and target include directory. I'm giving this. Is this okay? Correct. So similarly in client, how I'm building, I'm adding one more executable which is called client, and I'm using which CPP file? Client.cpp, this one. So using this, it will create the client executable. And similarly, I'm targeting which library? TCP client library to create the executable. And this is for target include directories. Fine. So all
Wait,
CMake are done.
what is the server and client in examples? What is the difference between those and TCP client and TCP server?
Yeah. So those TCP, see, when I'm calling this TCP client and TCP server, it will create a library, not the executable. The what this example will be, in this suppose in this example, if I in client.cpp, no, we'll use this library to create a client, whatever we are creating this library, or we'll use this TCP server library to create my server. So think of it like this, ki I'm creating these two libraries, and anyone can use these libraries to create server or client.
Okay. Okay.
Right. So this example, whatever this thing is, no, actually the executable is getting created here. So if you see two executable, one for the server and one for the client.
Okay. Is there any specific reason for creating library first and then creating executable
So
different?
no, it's so you can do it your way. You can directly create a executable directly from TCP client, but I'm thinking in the way that this TCP client or TCP server can be used by anyone. I'm making it as a library so that any third party can use my library to create
I mean,
server
it's
and
like
clients.
here we are the library writer, so we want to
Yeah,
like.
correct. Yeah,
Yeah, got it. Okay.
right. Okay, so now we are done. So let's first start with the TCP server. How we'll be writing a TCP server. So let's start. How will we define our API to how can we define our API so that it can be used by anyone, right? So what all APIs we can have. So if I go to TCP client, sorry, TCP server, let's see. So
Will we make
just
it
to
a C++
make,
class?
yeah.
Okay.
So let me see. Let's see how we can do it. So see, this is simple TCP server.h. I'm writing a hash defined just like .h and including. I'm creating a class from here. Here it is important. I'm creating a class and I'm defining some virtual functions. Can you see this? And these are pure virtual functions, so that anyone who will be inheriting from it has to define these functions. Right? These concepts are clear, right? In CPP. And then this, think of it like it is a factory. So anyone who wants to use my library first has to call this particular function, right? And this will give me what? TCP server ka type of pointer, this pointer, right? So inside TCP server.cpp, what I will do is, you will get the idea why I'm trying to do this. I'm trying to make my more code more portable, that's why. And you'll get it why. So in TCP server.cpp, what I will do is, see this. So what I'm doing is I'm including the TCP server.h file, this file. And then I'm checking if my platform is Windows. Remember, I have given this particular in the -d directory here in CMake list. So if you're Windows 32, add this platform Windows, right? So I'm using this in my CPP. If my platform is Windows, include the win.h wala file, which is inside this win.h. If my platform is Linux, include Linux wala file. If my platform is Mac, include Mac wala file, right? So depending on which platform you are building, that file will only be included, right? And in this create server wala function that I have to write the definition in the CPP file. What we'll do in the definition, what we are doing, if it is Windows, create a new Windows kind of server. If it is Linux, create a Linux server. If it is Mac, create a Mac server and then return it to the user. So definitely what we have to do inside each of the files. So inside linux.h, we'll have to create those classes, Linux ka server or Windows ka server, and that we have to inherit from this one, TCP server, right? Okay, so how will we do it? So inside
Amit,
linux.h,
just can you click on cmakelist.txt? I want to see how you define the variable, that
yeah,
platform variable.
this one.
Okay. But at runtime, like how will we decide? We have to give it on the command line while doing a
No, no,
build.
no, no. It will take it from here. So this particular variable, no, platform windows, while you are compiling it, this will go to your code. CMake will put it to your code. Keep this now. So using this, we are writing. So hash if def platform windows. So while compiling this platform windows would have come on the, if you are compiling on Windows, this would have been defined
But where,
because I have
like,
given,
this, yeah, platform
I
name
have given
Windows.
if on Windows, then only this is defined. Others are not defined,
And this
right?
Win32 will come from where? Like that also has to be defined somewhere.
CMake will take it from the system on which you are compiling.
Oh,
This
okay.
is this is from the CMake only.
Got it. Now, I've seen this code, but I didn't know it works like this.
Yeah,
Okay,
we
now I
did it
understand.
in the first or second class only.
Yeah, that I missed actually. Sorry. That's all.
Okay. So this will be available in your code to use it. Platform Windows. So that directly I'm using it here. So if platform Windows, include this file, and if platform Windows, create this particular class ka object, right? So what I will do in Lind, suppose, and now I have to write a platform specific classes, right? So what I'll do is I have to do this. So in here, I have to
Amit, I
create
have
these
one
classes.
question.
Yeah, yeah.
Uh, if I were to write all of the code only
Mm-hmm.
in like lin.h and win.h, including
Mm-hmm.
the definitions, I can go ahead and
Mm-hmm.
like make it like a header only library as well, right? Now that's up to me, right?
Yeah, 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 you can. So now anyone who wants to use it has to use your header directly. Have to put their header into their source files.
Yeah.
But right now, if you are creating as a library, they
Yeah.
just need a simple .lib file or .a file,
Yeah.
right? So what we have to include, we have to include this particular TCP server.h, right? Because we are using TCP server wala class, right? So I'll include this and okay. So this, so I'm including this and this I have to close has end, right? This is for this one, correct? So see, if you see here in TCP server.h, we have to define these three functions. So that's why we have put it in here. If you see, oh, where did I put it? Oh, I put it wrong. Inside, it will go inside lin.h, right? So I am creating a constructor, a virtual destructor, because it is a pure virtual function. That's why. And then these two functions that I have to override from this TCP server, correct? Any more functions? No, start. ठीक है, done. So these three things are done, and then we have to write as implementation of all this, correct? So for the implementation, if I do lin.cpp initialize and start and constructor. Okay. So for the constructor, I can do this. First I have to include that file. So include this one, lin.h, and then write the implementations. Sorry, this. And second implementation is for initialize. So I'll try to speed up and directly copy paste few things. Sorry. Any problem with what we are doing till now? Explicitly make the resource virtual in derived class when the destructor is already declared virtual. No, we don't have to write virtual. It will automatically take it as virtual if you even if you don't give it. So virtual and all concepts are okay for everyone, right? Or somebody is not familiar with it. Hello. So this
Yeah, we are
Linux
good.
server. Yeah. So these three things we have to define here, right? So what we can do in Lin server, initialize. So remember we are writing the initialize for server. So remember the yesterday's class, what we all have to do, what all steps we have to take to create the server. Anyone?
Create socket.
Yeah.
Create socket. Then define the address struct.
Mhm.
Then
Okay.
bind address to the socket. Then go for listen.
Okay.
And then after it is accept. Accept.
Okay.
Send, receive and send. Yeah. On the server side.
Okay. So do you think we need to take any state or something, put any state inside this? So if we can keep a state of client, suppose if inside this, this is public, this is suppose we keep it as private. So what I want to do is I'll keep a socket. So let's say, let's simply call socket, right? Let me see what I have kept. Okay. Server. Okay, this is for the server. Okay, in server, what can happen is we'll have two kinds of sockets, right? One is for the listening socket, right? On which we'll be doing accept and listen. And there will be other sockets which we'll get from the client. When we are doing accept, it returns another socket for the client, right? So let's name it right now as server if. Servers, yes, FD, can we write it like this? Okay. Okay. Okay.
We
So
can
now
also
what?
use a template here, no, for socket, because there it will be the WSOC structure in Windows,
There?
and here it will be int. So we can
But
use it.
we have a different folder for everyone. So in Windows we'll keep it different.
Okay.
So that's why we don't have to write a Windows specific code here, or we have to think about Windows here. That's why we have separated the whole code. Linux is different, and so when we'll be writing Windows, instead of taking int server FD, we'll be taking socket server FD, because their socket is defined as socket structure, right? Okay. Okay, so we have taken a server.
What does the FD stands for?
File descriptor. In Linux, it is always called descriptors, everything, whatever we take. So this is nothing but a int only. We can take any name you want. But this is FD is more specific to Linux. In Linux, we recognize everything as file descriptors.
Okay.
Right? So we need to now, so in server, what we'll do is, we'll initialize this particular thing with -1, so that at the start there is nothing inside this server FD, right? So how do we initialize? Sir, like this, right?
Yeah.
We
Yeah.
put it
Member
inside
variable
this
and
-1, right?
Yeah.
This is done. And initialize, what we'll do is, okay,
You can remove the default parameter
which one?
from the line number 5. You have already done it in the header.
Correct. So no need to give in the definition, because we have already given in header file. Correct. So in the initialize, what we'll do is the same code that we have written yesterday. So just check and let me know. So I'll quickly paste it so that we don't waste much time. So see, in initialize, what we are doing in the start, see out we are using, let's include has, or we have used it here, no? iOS stream, I directly use it here before this as include iOS stream. I'll use using namespace also so that I don't have to write std every time, but you can avoid this. For speed, I'm writing using namespace std now. So everything is gone. Cout is okay. So yeah, see, initializing the server, this will come on the console. This socket address structure, the socket we are creating, this will require some header files, right? So which header file is this is inside. So these all header files for the socket that we need, I'll put it here. So let's put here, it behind this. Yeah. Okay. So it will show error because we are doing on Windows right now. So on Windows, Windows will not be able to find this files. So that's why it is showing error. So yeah. So yesterday what we did was we are creating the address, we are creating the socket, and we are checking whether we have created or not. Let's give it on cout only. Socket creation has failed. And then this particular option I didn't show you yesterday. So this particular option is on Linux. It is telling that set the socket option. This will use a lot in our code. So this is very important API that Linux gives. So this set socket option, what it does is for this particular FD that we have created, I am telling I have to set some socket options. And what option that I have to set for this reuse address and reuse port, right? And this option I am setting it as 1. So this is how this API works. And what I'm telling here is, so what happens in Linux, no, suppose you are running a server, suppose on port 8080, suppose, and then it goes down. Suppose you are you have killed it, and then quickly you want to make it up or you want to restart it. So that port, no, that port gets blocked for some time by Linux, like for few seconds or something. So when you restart, you will not get that port, and it will say, "Okay, I'm not able to use this port," and you will get error. So to avoid this, if you'll write this code, that port will be freed instantaneously. So you will not get those errors. If you'll not write this code, only thing that will happen is if you'll restart instantaneously, like you killed it and restart, your port might not be available for it to be reused, and your server will not start actually. So this is why this code, so that this port can be freed quickly, and then my server can restart with the same port if I have to. This problem is not on Windows. This is pretty specific to Linux, that it occupies the port for some time. Right? Okay, so moving on. So after we have done this, initialize, what we'll do is we have to put address family and all, and we have to bind and listen.
Just a
Right?
quick doubt, Amit.
Uh-huh.
This set socket operation which happens, is it during the process only, execution only, or it will try to put some context such that after the process gets killed, it has to be freed? I mean, it has to be.
Yeah. So the moment you says ki this particular socket, whatever the port that I'll be connecting to this socket, no, that can be reused quickly is what this OS will get it from here, so that it will not block the moment it gets the moment this server is closed, it will not be blocked by the OS.
Okay, can be used again from starting.
Sorry.
So it can be used, that port can be used in any other process, any other application, or at least
Any other process also,
Nice.
any other application also.
Yeah.
Anyone. It's not pretty specific to process, but only thing is OS will allow it to be used. It will not block.
Okay. When the
Right.
application is running, it will not allow. But when the application is not running, it will allow.
Then it will allow.
use.
And it only happens for a few seconds. It's not like it will keep getting blocked. For few seconds, always keep it blocked. If you don't write this code, no, you just kill your process and restart quickly. you will see that you will not be able to listen on the same port.
Okay.
And this happens
Okay.
on Linux. Okay, so after this is all the same code that we have done yesterday. I'm trying to listen to any address, and I'm associating this particular port, which port I'm listening to, which will be, I'll get it from initialize, right? So this, anyone who will be using our code will tell ki, okay, I want to listen to this particular port. So that will come from here, and that I'm listening on this port. And then I'm doing the bind, and then I'm doing the listen. So this is the backlog. Remember, this is the backlog, second connect, second option. So instead of giving some particular number 10, 20, 100, I'm giving this as SO max con. And this is defined in Linux as, according to the system, like how much it is defined on your system, it will take that many kind of backlog, right? So you can also change it on Linux. So by default, I think it is defined as 128, but you can also change it. You can tweak it to like accommodate more bigger queue for the connections. So this is pretty standard that people use this. Instead of giving a particular number, people use this SO max con, right? So depending on whether you are on a better system, bigger RAM and all, this value can change system to system.
I think you had in your document also you had
Yeah.
mentioned
Yes.
about how to echo it to some value,
Yeah,
different value.
yeah.
I
So
tried it. It gave me 4096 on my machine. Yeah, cool.
Okay. 4096 high, very high value. If so these are the things that you can tweak to check which is giving a better performance, right? So this is SO max con that you can use. Don't think about any number, just use this and you are safe. And I'll put it as cout only, right? And my server, so see, I'm not doing any except here after listen. In initialize, I'm not doing any except. Why? So that I will
Because
do
you
in
need to
when
do it
someone
per
says
client.
start. Sorry?
You need to do it per client,
No,
right?
no, no, no. Except has to be there, no, to accept any connection. So how I am trying to design it is, when someone says initialize, it will be initialized till here. Like it will be ready for the listen and all is done. But when somebody says start, then it will start accepting the connection. So someone has to say now my server start, then it will start accepting the connection. So till initialize, I am just telling to initialize everything. But when I say start, then only I start accepting the connection. This is how I'm designing my library, right? So okay, so in start, what I will do is I'll start accepting the connection. So if you remember, we are directly going into that forever loop wala thing. Remember, forever we have to go inside so that we can keep accepting, right? So I'll just write a for loop and accept. So I'm keeping it slow also and little fast also, both at the same time. So I could have pasted whole code, but I don't want to do that because then it will become very difficult to understand. So I'm keeping it slow also. So yeah, so in start, what I'll do is remember the while loop, and inside the while loop, I have started accepting the connections, right? So this is the server FD that I have to listen to, and this client address and address link. This has to be defined. So this will be defined as like this. Fine. Any problem till here? This is something what we have done till yesterday also. We are accepting the connection. This client socket has come, and then we'll have to do something with this client socket, right? So what we did was that we were pushing it to the queue with separate particular thread, right? To handle this connection. Right? Everyone? Can we go ahead? Can we go ahead?
What if
Yes.
we wanted to have a stop functionality? Or like, I mean, I'm just recalling from memory that some servers they have
We
like
can.
play button and then stop button also, right? Some you can
So
stop the
instead,
server as well.
yes. So what we can do is suppose you are doing control C, if it is right, and you want to on control C, you want to stop the server. So you have to implement a functionality to take the control C, which is like a sigterm or something. And then on sigterm, you have to write something where you will stop all the threads and all this particular, you will say ki when I got that symptom, you break out of this loop,
Okay.
right? Then your server is stopped. So that thing you can implement. That these things I think you all guys can try after we have done no today. We can try. Good thing to implement. Yeah. So after this is our main code starts. Ki what to do after we have accepted the connection, right? So we have seen yesterday, right? Ki first we tried with each thread, each client per thread. Then that was not good enough, so we went to the thread pool, right? So now let's start with so what I will try to directly do here is, because instead of doing everything and then coming back, I think it will take time, and I wanted to do the Epoll today only. So what I'll try to do is, first let's go with the try to understand the concept of Epoll, and then we'll directly try to implement the Epoll here directly, instead of trying to implement the thread pool first and then doing that. We'll directly try to go to the Epoll implementation, because in Epoll also we'll need the thread pool. So in that time also we'll use the thread pool, right? Is it good enough? Because till the thread pool wala thing we have already seen yesterday, right?
Yeah.
Okay. So let's directly go to the concepts of Epoll, what Epoll is and how what all we need to do to and why do we need Epoll actually, right? So if we remember, I'll just put some comments here. So can anyone tell me what was the problem when we were using thread pool yesterday? We discussed this, but I just want to hear it from someone who can tell me what was the problem with the thread pool that we are using to serve our clients. Come on, anyone.
If all the
Blocking.
threads are busy, the new clients might get starved.
Yeah. Okay. Correct. So is this clear with everyone? Why thread pool was not good enough? So remember our receive and send were the blocking calls. So until someone is sending and receiving, that thread is blocked for that particular client only. So if suppose we have a thread pool with 8 threads, and all 8 threads are busy serving the clients, so if the ninth client comes, it will always be in the pool of the thread pool and it will not never get any chance for to get it served, right? So that was the problem. Even if some client is not even sending anything, this receive will get stuck there because it will just keep on waiting for some data to come, right? And similarly with if I'm sending something and if there are a lot of big data to send, and my system is not speed enough to send everything, so if my buffer, the send buffer is full, and if I'm doing send at that time, it will keep on waiting until there is some space in the buffer to be sent again, right? So at that time send will also be stuck. To avoid those problems, what we can do is, so yesterday we were talking about, if there is some mechanism to tell ki, right now I cannot do receive because I am not getting any data on the receive, on that receive buffer. What if we just give the thread to somebody else, to someone else to serve? Let it get back into the pool and let's see if I can serve other clients. While if any data comes on the receive, I'll just have some event mechanism to tell my process that, hey, you have got some data on this particular socket to receive. Now you can receive. So at that time, my thread will come here and then do the receive again. Then at that time, my receive doesn't have to wait, right? Because at that time, I'm sure that some data will be there on the receive, because at that time only I'm getting the notification. Does that solve our problem? If something like that can happen, right? Everyone gets this. This is very important that you get this. What problem we are trying to solve and how we can solve this problem. So instead of blocking on this receive, what if we do not block on this receive if we don't have the data, right? So for this, we will be using Epoll. And Epoll is what? Event notification mechanism. Right? So this is Epoll is nothing but event notification mechanism, and it has 3 APIs that you have to use to work with the event Epoll. So the first API is API first API is epoll underscore create, and then we'll be using the one wala API. There is also API epoll create, which is the older one. We'll use epoll create one, right? So with this, we'll create a epoll, which will nothing but give me a similar FD like we get in socket. So that in epoll, this is think of it like a handle for this epoll create. So we'll be using this FD to work with the epoll, right? So this is just a simple API to create a epoll, just like us we were doing for the socket. So socket, when we create socket, return some FD, right? And then we use that FD to do everything, listen and accept everything. So similarly, epoll create. This is the first API to create the epoll. Second API is epoll underscore CNTL. One second, it is CNTL or CTRL? Epoll score CTL. So the second API is epoll underscore CTL, right? So in this, what we have to do is we have to tell key which all for which FD for the socket wala thing, which all sockets that I want to put inside to receive some event for this, and what kind of events I want to listen. So two things. One is for which sockets I want to listen for the event, listen for event, and the one more parameter is which kind of events. So event could be something like event could be out event, like when we are sending, that is an out event. When we are receiving something, that is an in event, right? And there is also event called error event. So these three events I can define for a particular socket that for this particular socket I want to listen for, suppose incoming data or outgoing data, or the error or any error has come. I can define it in using epoll CTL, right? Correct? This makes sense. If for which particular socket I want to listen for which kind of events. So suppose any particular socket, suppose on server, I want for a particular socket, the client socket that is connected, for that socket I want to listen for receive also and send also. So I can give here. For any particular socket, I just want to listen for only incoming events, only receive. So that I can give here, right? So that you can decide according to your logic. And then the third one is epoll wait, right? And in this, what will happen is int number of events. Let's call it this. Inside epoll wait, what it does is it's kind of a blocking call now. Epoll wait itself is a blocking call, which it returns what? So suppose in using this particular API, you added 4 FDs, 4 sockets, and I'm telling that on these 4 sockets, I want to receive and send both, right? So what will happen is if some data comes for which, suppose for 2 FDs, some data has received, and for 2 FDs, data has not still been received, right? So what this epoll wait will return is only 2, because only on 2 FDs the data has been returned, right? And inside this, whatever you will send, you will also get the on which FDs you have received the data, and then using those FDs, you can do a receive on those F2 FDs. Right after this has returned, you will get how many FDs you have got the data and which kind of get data. Is it for receive or is it for send, and for on which FDs. So what you can do is on that particular FDs on which you have got the data, you can directly tell, okay, now I have got the data, now I can do a receive on that particular FD. So at that point of time, this receive will not fail, right? Or it will not get stuck. Are you getting the point? Now, is this three things clear? Then we'll start writing the code.
One question: why would we need epoll wait on send? Like which situation?
That's what I said, na, ki why, when send can also become stuck. We are talking, right? Ki when send can also become when send can also become blocked. Right?
Okay, but
So the send
we will
buffer
know.
is full.
Yeah, correct.
Okay.
While sending, it might happen that the OS has not been able to send that much data. Your buffer, the send buffer is still full, and your data, what you are trying to send, is not still get copied to the OS ka buffer.
Okay.
Right? At that time,
Okay.
this send will also get blocked. So
Okay.
if you don't want to get blocked, what you can do is, for that also events, I can post an event to the Epoll telling ki if you have space in your buffer for the send, then only it tell me, give me an event. At that time, then I'll send.
Okay, but it will keep sending if there is space.
If it is
No?
space, then it is fine. But if it is not, if it doesn't have space, then
Okay, so it will only tell you when it doesn't have space.
no, it will tell you when you have space so that you can send.
Okay. Okay.
Getting
So I
the
have to
point?
register
notifies you,
and
it
unregister
sends.
it. When I don't want to send, I have to unregister also then.
Yes, yes. If you want that now you are done with this and you don't want to receive event for this particular FD, you have to even delete it from their queue.
So you can dynamically add and remove from
Yes,
Epoll
you
CTL.
can.
Okay.
Yes.
And
And
how
I'll
do
show
you
you
get?
the code.
Okay. And how do you get the file descriptors in Epoll wait? In num events, we get two files descriptors are ready,
In
but
this,
then
there are some parameters that will be passed. That
okay,
is out parameters. In that parameter, you will see ki
fine.
these events have come for this particular file descriptors.
Oh, thank you.
Right.
Amit,
Anyone has confused?
before you go ahead, so two questions. This Epoll wait is going to be running in some kind of a loop.
Yes,
I mean,
correct.
right.
You are right. It will throw you some events that it has come. You will put it to some so some receive has, now you are ready to do a receive on some particular FDs, right? After it has returned something, you will post these events to some thread pool. So now you can do the job, and then it will quickly come back and do a Epoll wait again to see if other events is coming. Are you getting the point? Yes, you are right. It has to be in some infinite loop.
And second question
Right.
was, is it important to know the details of how Epoll wait is actually generating this notification?
See, internally, for the coding part, you don't need to know.
Of course,
If
yeah.
you just want to know ki how it, so internally OS will be maintaining a queue. Whatever you will add it from, it will put it in the queue, and the OS will put a callback mechanism. So it will put a callback there. So if suppose receive buffer has been something came in the receive buffer for that particular socket, OS will receive a callback, and then it gives you a callback to the process through this Epoll wait. Something like this is happening inside, right? But then you don't have to take care about it as when you're writing this Epoll. Okay, so before I'm trying to write the Epoll code, these things has to be very clear. Why do we need Epoll? What problem you are trying to solve? And these three APIs, what these three APIs are doing. If it is clear, then we'll start writing the code. Otherwise, before we start, please ask if you have not understood this.
Hi.
Yeah.
Actually, I didn't understand like proper. Like the first one, like create like how many like FDs will create for each sockets, that I didn't get, and also like
Which one? This
this
one, Epoll
create,
create.
it is like one time it will
This is
create.
one time thing. This is one Epoll that you have to create throughout your server.
Only one it will create, or multiple it is?
One Epoll create will be only one.
Okay.
We'll be using that same Epoll for everything.
Now with this FD descriptor, what it will do actually, it will either listen or send whenever there is a blocking call, right?
No,
Like
this
when
this FD is for Epoll. This is not
then
the socket.
okay.
Right? So inside this API Epoll CTL, right? Inside this, we will be adding all the sockets on which I want to listen to events.
Okay.
Right?
Okay.
Okay, let's do this. We'll write the code, and I think that things will make better. Things will be clearer.
Yeah.
But at least keep these things in mind with these three events.
And Amit,
okay, we'll revisit this again to understand, right? After writing the code.
Yeah. So Amit, like these, right? Like Epoll create, Epoll CTL, all these are like also system calls.
Yeah, these are system calls only.
like how we have a receive and send our system was the same way
Yes,
these are
yes,
also.
yes, 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 yes. Yes, correct.
Amit, an
Okay.
equal weight is the blocking call, right?
Weight is the blocking, or you can also make it non-blocking, but for our purposes, we'll make it a blocking call
Okay.
because we don't need to go ahead we will not gain anything by making that as a non-blocking.
Okay.
And similarly, Amit, we can also make send and receive also non-blocking, right?
So we will have to make it non-blocking for this particular scenario. When we'll be using Epoll, we will have to make it non-blocking. I'll show you. Okay.
Sure.
Okay. So we realized one thing is that we need a separate thread to do a blocking to continuously loop inside that blocking call of Epoll wait, right? So I'll be making a separate thread for that, right? So let me write the code. I think it will become clearer after I write it, right? So in server start only, in lin server initialize. So while starting, let me put this here. We can put it in initialize also. That's not a problem. I'm just putting it here. And this Epoll thread, no, I can put, I'm making it as some private variable. So thread Epoll thread. I'll need a has include thread. Right. So this thread will be dedicated to loop inside a Epoll loop for a Epoll wait. So that I'm dedicating a thread for it. So this is that line for, right? This one. So I will have to write what this particular function also Epoll loop. So let me write this later. First, just I'll define the signature here. So void Epoll loop and this here, and it will be for the len server. And this will I'll put it inside my len.h. And this is I don't require it to be a public because this will not be used. So I can keep this as private. This is not going to be used by any other third party. So I'm keeping it as private. Epoll loop. Now this is done. So now this I have dedicated. Now what we need is a Epoll ka FD, separate FD, because throughout our server there will be one Epoll that I'll be using, right? So what I'll do is I'll initialize one Epoll. So I think we'll do it in initialize. Server FD, okay. So this thread also you can put it in initialize. That's not a problem. It will be similar only, same thing. So initialize after, let's say after set socket opt, I initialize our FD. So this FD and this particular FD, I'll put it as my private member variable that I can use it everywhere. So Epoll FD, and this is nothing but an integer, right? And this Epoll, I think, is in a separate header file, or I think it is in net only. So okay, if we'll see the error, we'll correct it that time. So this Epoll FD is nothing. We have created a separate member variable Epoll FD. And what we are doing is we are creating Epoll. Remember, I told you Epoll create. I'm creating FD and I'm assigning it to my variable, member variable. And I have to check the if it returns -1, then I was not able to create the variable. So I can just return false from here. So this bool false, it will say that I am not initialized. I'm just put the error. Is this clear? Is this clear? I'm just creating a simple Epoll. This is the API to create it, and I'm assigning it to my member variable so that I can use this now anywhere in my all my lin CPP. Correct? Is this clear?
What does zero indicate?
Zero is indicating that I'm so Epoll create one is a more modern this API. So earlier it was Epoll create, but if inside Epoll create one, if you give zero as a flag, then it will use it like as that earlier Epoll create wala API that you can read. But simply you can give zero, it will create. For our purposes, that is okay. We don't need to. There are other flags that you can give, but that is okay. We don't need to know right now. Fine. So you know this is how you create a Epoll, and this returns me a FD that is associated for this Epoll. Right. So think of it when you will be writing this particular function internally, OS will be creating some queues and all for you. Some buffer and all has been created after this to use this Epoll. correct? And this Epoll FD has been written, which is now associated with that Epoll. Okay, so now moving ahead, we have created an FD. Now what will happen is, think about this. So once we are in accept call, I have got this client socket. What I want to do is, I have to do a send and receive on this client socket, right? So instead of doing this in client per thread or thread loop, what I'll do is, I'll tell, let me, so first I'll tell, let me make this socket non-blocking. And what is meant by non-blocking? So this is also one concept that you have to see. Non-blocking socket, right? So whatever the socket that we have seen yesterday, receive and send, whatever you are using, you are creating with the socket, those were all blocking sockets. So whenever I saying receive, right, I was saying if it doesn't get any data, it will keep on blocking. But the moment I set my socket as non-blocking, I'll tell you how to make the socket non-blocking. The moment I set my socket as non-blocking, what will happen is, now anytime you do a receive call or even a send call, right, on that particular socket of whom you have made it non-blocking, before I was saying it will wait, right? But now after making it non-blocking, it won't wait. Now this will be a difference. So suppose you have some data in the buffer to read, it will read that buffer, it will come back. But if you don't have the data to read, earlier it would have been waiting on that thread, right? It will be a blocking, but now it won't be a blocking call. If it doesn't have a data to read, it will just quickly come back and return. This will be the difference now. If for similarly for the send, if the memory buffer is full for the send, it will quickly come back. And now as a user, you have to handle what to do now. So what we'll do in that case, we'll put it in the Epoll wala loop. Now whenever it comes, then you notify me. Is this thing clear? Non-blocking thing. So now this, whenever I make a socket as non-blocking, these two APIs will quickly return if you are not able to do receive and send. It won't block. Earlier, without using non-blocking, it used to block. Getting the point? Is this clear? Non-blocking. Come on, guys. Yes, no, these are very important concepts we are going through.
Amit,
Yeah.
so can you just tell if my understanding is correct? Like Epoll is like non-blocking IO.
Epoll is like?
Non-blocking IO queue.
Epoll is like a, no, don't think Epoll as a non-blocking. Epoll is something like an event notification mechanism, that a tool. Think of it like a tool that OS is giving you. So whatever I tell to the Epoll that, see, I want to listen to this event on this FD, Epoll will give you a notification whenever it is ready for that, receive or send.
Epoll is a kernel level thing that is allowing you to keep polling the receive and send buffer.
It's sockets.
Yeah, okay. But I'll tell you what, you'll get to understand what Epoll is properly. But did you understand, everyone does understand what is the meaning of non-blocking? And what will happen if I make my socket is non-blocking? What difference does it make when I make my socket is non-blocking? Then we'll move forward. So what, does everyone get this? Can we move ahead?
Yeah, Amit. Non-blocking means like you are trying to free the thread, free our worker threads and make Epoll to work for that.
No, when I'm making a non-blocking, only difference before making it non-blocking is this receive and send all the APIs will quickly return if it is not able to do that. Only this is the only thing.
Any function, if you make it non-blocking, it will never wait on it. It will immediately return some return code, even if
correct. Yeah. If it is able to do that, it will do it. If it is not able to do it, it won't block. It will just return.
So can
this
we
is
say
the
that
difference?
So can we say that non-blocking is like short polling in terms of HLD?
Non-blocking is
like short polling in terms of HLD.
Acha, that you are sending a connection, if you are getting But there we keep sending lot of
So if there is
send will
nothing,
be
then
doing.
that also comes that, right? Short
Will
polling.
not be doing that, no? That is what I'm saying. Okay, let's go to the code and we'll see how. So
Amit, it blocks the blocking receive wala, it blocks the thread or it blocks the call, like exactly like what.
if call is blocked, your thread is blocked only, na?
But so it overheads non-blocking means it thread is not blocked, right? So it will
Yes. So if it returns back,
it will
you will
return
decide
the
what to do.
huh.
As a code, you have to write something. So if I have returned and I see ki either I have received the data or either I have not received the data.
But like if like the thread is suppose it is doing some other task, it has returned nothing is there in the receive buffer and the thread is doing some other, so that will be interrupted and again it will be pulled over here.
I didn't get the question. So suppose receive came back, like
So
suppose
there
no
is
data
nothing
was.
in the buffer in the receive, like
Okay, so receive
so,
came back quickly.
yeah, so the thread came back and added to the FDQ you're saying, so like it will do some other task, right?
That's what I'm saying. You will decide what to do now. You will tell the thread ki okay, now you go and do other task.
So now again now the buffer came.
Now when the buffer comes, how will your thread know when the buffer came?
So then the whatever
And
task
it will
is
come through
doing.
Epoll. That will come through Epoll.
So whatever task the thread is doing, suppose other task that will be interrupted and again it will come over
So
here.
that will not be interrupted. It will do its task and then it will come back and do that task. So remember the thread pool concept. Remember.
Yeah. So like 8 threads, parallel threads will be do
So
parallel
suppose
tasks.
one thread is doing some task. Once it has done that task, it will come back to the taking new task from the queue.
But sometimes it can be delay, no? Like all the task is doing some other task and the buffer came over here. So then like over there
In that time it can be delayed, right? So you are telling 8 threads are doing some other task, and at that time receive has come, but still there is no thread that has to pull that task, right? But in that case, what we are doing is I'll be taking that task and put it in the queue. Whenever that thread is free, take out that task from the queue.
Okay.
That's the only thing we can do. So whenever I receive from the epoll, that now the receive buffer is some data is there on receive buffer. What we'll do is we'll put one task into the queue. Now you can do a receive.
Okay.
Right. So let's see. So first of all, how we make this any particular socket is non-blocking, right? So we'll write a separate function and that I'll put it here so that I can reuse this. So len.cpp inside this I'll put maybe after somewhere I'll put it here. So let's see. I'm using this function. I'll put it inside .h also, and we'll not use it from the outside. So I'm keeping it as private member like this. I don't need this here. Right? Yeah. So inside, see what I'm doing. So this you can all means this I'm telling I'm giving you a socket ka FD or ID, whatever the client socket or anything will be there. I'm using this API to take out the flags of this particular socket. So this is telling me f_get flags, right? If it is not equal to 1, then it is returning me I'm not able to get the flags. But if you get the flags, you are ORing with O non-block. This is one flag that I'm whatever the flags that was already there, I'm ORing this flag with the O non-block. And then again, I'm using the same API, and instead of doing f gets fl, I'm doing set fl now. I'm setting this particular flag, whatever after I've done this. So if it is not set, it will return false. If it is set, it is returning true. That's that. Now your socket is in non-blocking mode. Simple. That's it. So this code you can reuse to make any socket non-blocking. So after this, when you have set non-blocking, now any receive and send will return quickly if it doesn't have anything to read or send. Right? So nothing much to explain here. This is just the API that you have to use, Linux API. Get the flags or with this non-block and then set the flags back for this particular socket. That's it. Fine. move ahead, right? So we have got the API to set any socket as non-blocking. So now what I will do is, where should I set the non-blocking? So see here, while start when we have done select, we have got the client socket at that particular point of time only. What I'll do is here. So right now I have not got the error. Everything is okay. So I'll set the client socket as non-blocking. Right. So I'll call this function set socket non-blocking, and this particular client socket I'll make it as non-blocking. So now whatever happened on that particular socket now, so we'll be doing receive and send on this socket only, right? So now it will become a non-blocking. Those receive and send API calls will be non-blocking API calls. Fine. Is this clear?
Amit, where is client socket defined? Like in
This
if
one.
condition, we are just
We didn't
treating it.
define it actually.
Yeah.
In client socket. Fine.
Yeah.
Okay. So every time a new accept comes, we'll take that client and I'm putting it as non-blocking. Right? I think till here it is all okay, right? Till here it is all okay.
One question, maybe slightly I'm digressing, but what happens if I do a receive on the original socket? It will just not have anything, right? Like we can do it, or it will crash, or it will throw
Which
exception.
one? This server FD?
No, yeah.
Yeah, I don't think it will happen anything.
Yeah,
Only
right,
thing
right.
you can do receive and send only on this particular socket.
Correct. Correct. No, why? Because you don't need to do that socket as non-blocking anything, right? That
You
can be left
can,
as it.
you can, but for now I am leaving it. But you can. What will happen is, for this particular server FD, no, you can also make it non-blocking, so that this particular accept is non-blocking accept call.
Oh,
So
okay.
remember, my accept is
Okay.
also blocking call. So until there is client any connection has come, this keep on waiting here, right? Remember.
I see. Yeah.
So if there is no connection, it will quickly come back.
Correct.
Right? So this also we can put it in Epoll. If any connection come, then you come and do accept.
Okay, perfect.
That also you can do. But right now I'm keeping it little simple for the starting. So I'm letting it be a blocking call only, so that any connection come, then I'll take this, because I'll be this is because remember, this is my main thread.
Right. You're right.
Right?
Yeah, I got it.
Okay. So set non-blocking, and after I've set it non-blocking, what I can do is, now I can put this particular client socket and put it inside the Epoll. Any send or receive, now you want to do anything, that suppose any receive comes, that my my thread will know okay, some receive has come and now I can receive the data. So here only I will do is this. So this is the important code, that I am putting my socket, this client socket, into this Epoll CTL. Remember this second API to add the socket inside the Epoll. And what I see, what I'm doing. So this is particular structure that you need to create. And inside this structure, you have two things. You have events and you have the data. This is the structure. Inside this Epoll event, they have two things. So think of it something like this. Internally, it will be something like this. Epoll event. Internally, you have two things. Like one is events, which is some other, and the other thing is data. These two are there. And this data also is actually a structure again. This data is internally also a structure, which is nothing but a union of int fd and void star pointer, like this internally. Right? These things I put it in notes also, that you can check. The theory that you should know, this is how what the Epoll event is, how the Epoll event structure looks like, and this is what this particular data looks like. So this is, when you say union, means what? Either you can put this or this, right? Remember? Okay. So I don't need, I'm creating Epoll event, and inside this events, what I'm saying is, on this particular socket, I want to listen for in also, out also, and this is edge triggered. And there is a concept inside the Epoll that I will discuss a little bit. So Epoll could be of two types. Epoll, whenever you are adding any event could be of two types, not Epoll. Epoll events could be of two types. One is like this. One is level triggered. Second one is edge triggered. A lot of concepts today, but you just have to know it once. Otherwise, once you know it, then done for the lifetime, right? So Epoll events, when you are putting into the Epoll, this could be of two types. One is level triggered and what is edge triggered. And what does that mean, right? So when you are putting some event, so see here how I'm putting events. So I'm saying events, I want to listen for input also, which means receive, out also, which means send, and I'm telling it is edge triggered. So what will happen is when you are putting it as edge triggered, whenever event notification come, no, this triggering will happen only once. So suppose some data came, right? And you did a receive, but you are not able to receive all the data at one point of time. So the next time Epoll notification will come, if it is edge triggered, it will not give you the notification again. But there is something called level triggered. If you are doing a level trigger, until you have received all, you have read all the data from the buffer, it will keep giving you the notification. Okay, again you can read, again you can read. But in edge triggered, it will only give you notification. Then as a user of this, you have to make sure that in one receive call, you copy all the data. Otherwise, next time it won't give you the notification. Next time it won't, when will it give notification in edge triggered? When the new data comes in the receive. Remember, is it clear? Edge triggered, level triggered.
But how can I copy all the data till I don't know the size?
So as a user, you have to know how much data that you have to read. So
From
suppose
which
some
API?
data came.
From receive, we get to know how much data is there in the data received. API will give us that.
No. So suppose you give a buffer length, right? When you are receiving the data. So you have to know how much data could have been sent by the client at one piece, right? So you give some big
receive
buffer.
Call gives the length, no? Receive call gives the length of bytes received or something like that.
So that is how much you have read.
Right.
So suppose you are sending some buffer, like suppose 100 bytes, but your receive was 200 bytes.
Correct.
You actually received 200 bytes, but as a buffer you send 100 bytes. So 100 bytes was not able to copy, right? Right. So 100 byte was still left in the buffer, kernel ka buffer, that socket buffer, right? In OS. So in edge triggered, the next time it won't give you a notification that see 100 buffer is still left. It won't give you will not be notified to do receive. But if it is level triggered, you will again be notified ki 100 buffer is still left, you can again read. This is difference between edge trigger and level trigger. So in level trigger, it is it actually keeps giving you until you have received all the buffer. But in edge trigger, it will give you only once. It will, when the edge trigger will give you notification again for receive when the new data comes in the buffer.
So
right?
that's what my question, that how will we know that how much data is there in the buffer so that I can appropriately
So that's what I'm saying. As a user, you have to decide if I'm giving this much buffer, I should be sure that I have read all the buffer.
But then sometimes in TCP and network, there are jumbo packets and all those things, right? So you can
that can happen. That's what. So there is a thing you have to decide. So Epoll, this edge trigger, no, this has a higher throughput. So if you realize it will only give you a notification only once, right? For some buffer. But level is giving you, so it is
level is low maintenance.
Huh?
Level is low headache.
As a user, you have to write less code. You are sure even if I don't read it, I will come back again. So you have to decide as an algorithm whether you are okay with doing edge triggered because it will give you a better throughput, but you might lose something. Right? But in a level trigger, it will keep giving you notification again. So it might make it will be doing a lot of CPU cycle also will happen, right? If you are giving notification. So it will make a system little slower, but you are sure that even if I miss something, I'll get the notification again. Right. So that as a user, you have to decide what system you want to build. whether it is more throughput build system or more sure system. I have read everything, right? So in computer science, everywhere it is a trade-off.
Amit, just to confirm, the level trigger will keep on giving a notification until the entire buffer is fully read.
Yes.
Okay.
And edge trigger will only give you notification whenever the new data arrives. Clear? Edge trigger and level trigger.
And which Epoll system call tell us that yeah there is some data? Is this Epoll CTL?
No, I'll tell you. We have not reached that part.
Amit,
So right now,
sorry. If you are sending data, when the send buffer, only when the send buffer becomes empty, will edge trigger give you like
correct
notification, correct?
You understand, like, right? Edge trigger is just once kind of a thing. It won't be bothering you every time again and again. Right. So, and if you don't give this edge trigger, by default, it is level triggered. Okay. So if I want to have edge triggered, I have to give it like this. I have to keep this flag. Epoll edge triggered. So this is Epoll, ET is edge triggered. So Epoll out is for I am trying to listen to the outgoing events, which is like send, and Epoll in is for I am listening for the in events, which is for the receive. So these are the events that I want to listen, and for which thing. So in this FD, this data ev.data.fd, that you can put anything. So suppose when you get the notification, you want some state to be maintained. Suppose if you have some business logic. So suppose you read something and then you were interrupted and you did not read everything at once, and then you again came to read through Epoll, right? So towards that you want to maintain some state, how much you have read or not, right? So that those things that you can give it inside the data. So in data you could give any structure, right? So right now I'm just giving a client socket, right? But I'm telling you in data, just like I showed, data can have a union of integer and void pointer also. So with void pointer, you can give any kind of structure, right? So Ankita is
Like
asking
callback.
which scenario edge triggered gives advantage. When you want to have a high throughput system, edge triggered is better.
Amit, I have one question. So generally in TCP, whenever we send data, it's sent in segments and we get acknowledgement after each segment is received, right? So that acknowledgement, like suppose if it's edge triggered, so do we get that acknowledgement when it is received at kernel level or when it is received?
No, when it is pushing the data in our buffer.
In our buffer, right? So like
No,
suppose
not in our kernel ka buffer.
Okay.
Receive and send buffer.
Okay.
So that I can do a send and receive and it gets copied to our buffer.
So like suppose if it only half of the data gets copied in our buffer because of edge triggered scenario, then so it's kind of a false information, right? That like
so
whole
if you
segment is
took only the half data is still in the buffer.
Yeah.
So you will not be triggered until a new data comes to that buffer.
Okay. So at that time we can read the previously
At
not
that time
read
again you
data.
can read. There is no problem. That buffer is still be there. That will not be lost. Only thing is you will not receive the notification.
Okay. Yeah, got it.
Got it. Okay. So this part clear to everyone? This
Yeah,
part
Amit,
is
one
important.
last question.
Yeah.
In the receive buffer, will the kernel make all the segments into one part and put it in the buffer, or is it like it will have
No,
different
not all
number of
segments.
segments?
Because it doesn't know how much buffer I'll be receiving, right? It could be because these are streams that in TCP everything is stream, right?
Correct.
It kept on receiving packets and it will decide, okay, this much buffer I have now. I can put it in the receiver buffer.
Okay, it you mean to say it aggregates all the frames that comes on the TCP stream and puts into the receive buffer and notifies the application, user application.
Yes.
Thank you.
But then it could be keep on receiving also data. So some data it has received, it will put it on the buffer, and still it is receiving it. It accumulates some data and then keep putting it on the receive.
And
In
notify
particular,
the
in proper order. So ordering we don't have to maintain. That's what TCP will be doing. TCP stack.
okay, all that processing will be done and kept in the buffer.
Yes.
Right?
And then we can read from that buffer.
Okay.
Basically, when we are doing receive from that buffer, it gets copied to our buffer.
Yeah. Perfect.
Okay. So add, how do we add any event to which particular FD? Is this clear? So remember this Epoll FD that we have created for this particular Epoll, I am adding. This is for the add. If I have to delete, I will do Epoll CTL underscore delete. If I have to modify something, so suppose for this particular FD, earlier I would have added for the receive and send both, but now I want to just for the receive. So I can do Epoll CTL modify mod, and then I can change the events here like this. So this third parameter is for which particular FD you are doing this add. This and then this event. What all events you want to add to Epoll in, Epoll out, and what particular data that you want to add. So this data could be used to maintain state information between the calls, right? So this is how you add. Now, how do you get the information? How do you get the notification is the third call. Remember 3 calls. One we had created, this one we have added, and third we'll listen to how we get the notification, right? So this is, remember, this is the main thread, right? In the main thread, what all we are doing, we are accepting the connection, we are setting it to non-blocking, and we are putting it to the epoll. That's it. So these things will be take very less time, right? Setting non-blocking and putting it to, we are not doing any receive and send here, so that it takes time. So my this particular main thread is free to go again back to the accept to accept new connections. So I'm trying to minimize the work in the main thread so that my thread is free to take more accept connections, right? Clear? So now we'll move to the third part, how to listen to the notifications. Can we move?
This Epoll FD, therefore, should be some variable which should be accessible even to that way, even to the loop, right? Then because
yes, that's why we have kept it as a member variable so that we
Achha,
can
it's a
use it
member
anywhere.
variable. Okay, cool. Yeah.
Remember, this is lin.h, Epoll FD.
Cool. Yeah.
Right. So now remember, we had one loop that we had created, a separate thread for Epoll. Where did we create? In initialize. Remember this thread? Right. So this is the particular loop where we'll say if we are waiting for the events. So if we see what code. So what we'll do is we have to be in inside while loop so that we are continuously listening for that. That's why we have made a separate thread for it so that it is not getting interrupted by anyone else. I am not using even the thread pool for it, a separate dedicated thread for it, right? And there should be something inside while loop. So inside while loop, we will be doing a wait. And how do we wait? Is like this. This is the third call for epoll. If you understand this, our epoll is done. So see this. So we have to define epoll event. So this we have defined. Okay. So max events that we can give, how much. So I'll tell you what this API is, then you will understand what is max events. So this is the call, epoll wait, right? So this is a blocking call. So this epoll wait is a blocking call, right? So if there is no event that is happening, so this particular thread will be waiting here. And so what are all the parameters? So one is the epoll FD, on which epoll FD that we have created, this particular FD that we are trying to wait on. Events. So this is particular epoll event. So this is the same, if you see, this particular event, epoll event, it is the same structure. But right now we are using the array of these structures, right? So I can just define my int max event supposed to be, let's say for right now, I'm defining it as 10. So I'm defining an array of this particular structure 10 particular structures of this, right? Epoll event. And I'm passing it as the second parameter. And then I'm giving the max events and then this -1, right? This the last one tells you when I'm giving this -1, this tells you that I'll want to make this Epoll wait as blocking. It will wait infinitely until it has received any notification. You can also give some, suppose if I give 10, so it will take it as a timeout. So 10 seconds timeout or 20 seconds timeout. So if I don't receive anything till 10 seconds, it will come out, like it will return. But if you are giving -1, it means I am blocking infinitely. So these parameters are clear.
Sorry, what is max events again used for?
So I'll tell you. So first of all, what is this returning? So what is this returning? What will be in my event count? So suppose remember here, we are adding the socket. So suppose 10 clients came and we added all the 10 clients for Epoll in, Epoll out, Epoll it, and we have added 10 sockets to receive notifications. If anything comes, either for receive or send, right? That's why we have it in and out. So suppose only on 2 threads receive came. It can happen. Oh, so not threads, only on 2 clients receive came, right?
Okay.
2 sockets. So this event count will be 2.
Okay.
Right? So this signifies on how many events that has come.
Agree.
Right? And this max events is you are so suppose there are 10 clients, right? Right? And we suppose it could be like, so take an example where I have 100 clients. Right? And suppose in all the hundreds I have received some notification. So all 100 are doing some receive, suppose. But taking all the 100 receive at a time will make your system little bit less lag. It will make you less laggy. It will become more laggy. So I want at one particular point of time, I just want to receive 10 events. Even if you have got 100 events, you just notify for the 10 events. And then next time I'll come, you then notify other one. So why I'm trying to do this is, why I want to control this is, why I don't want to listen to all the 100 notifications at once, because I want to take all those 10 and whatever I have to do, I have to do receive or I have to do send, I'll put that in the queue, put that in the thread loop wala queue, right? Thread pool wala queue. You do start doing this event while I'll come again and I'll start doing that I'll start taking other notifications. So this you can tweak for to understand how much better throughput your system can give if you change the max events. So generally for a real system, which if you want a more throughput, people generally give the data between 100 to between 200 500. And people tweak. If I'm giving 200, then is it giving me better throughput? Or if I'm doing 500, is it giving me better throughput? So these max events you can tweak to understand which is giving you a better throughput. So did you understand what is this max events? So max events is, this is the maximum number of notifications you can give for one Epoll wait event. Epoll wait call. Even if more number of notifications are there, it won't give you more than this max events. Then you can go next time you go again, you will get the notification next time, not at this one point of time. Is this max events clear?
Isn't it the case
and is this event count clear?
Amit, shouldn't we then be, we will, supposing if there are 100 clients, but I am going to at a time only capture, suppose 10 notifications like you have done. Right? So event count will become 10 and this Epoll wait system call will store those 10 sort of like whatever data in that event structure.
Yes.
Okay. Now, then when this while loop runs again, second time, I want the remaining notifications also to be picked up. In the second, because that's a second invocation of Epoll wait. Then shouldn't it be like level triggered?
No, that level trigger is for the buffer that you are receiving, not for this Epoll wait. There's a difference.
Okay.
Level trigger, edge trigger is when we are defining this, when we are adding that event for this particular socket.
Okay.
So this is for if some buffer is, if some data is getting received in the buffer, receive buffer or send buffer is getting empty. That concept is level triggered and is triggered for that thing, not to how many native notification we can get.
Okay, so
Right?
the 90 notifications will be there even after this
It
10
will be
have
there.
been
Next time it will be picked up in the next call. Right. So see, so once we have given event count on these many number of FDs, I have got the event. What is the more natural way to do to handle all these events? We need to have a loop, right? For these many times event count, right? So we need to have a for loop from this. Tell me if this is understandable. Right? Is this correct? So now for each of the event, I will try to decide what I have to do. Right? So see what I'll do is.
So, Amit, before going ahead, I wanted to ask one thing about max events again. So, max event, you are saying how many events we want to listen to in one particular go, right? We want to
Yeah,
get
this is the
notified
max
on.
events. So if it is less,
Right.
it will give you all the events. But if you cannot go beyond this event.
Okay, and you are saying that we need to tweak this number based upon our requirement, right?
Correct. You can tweak this number to see which is giving you a better throughput. So while
But
doing profiling, you can do this.
But Epoll also does the same thing, right? That's why we are using Epoll, because if we try our own polling mechanism, then we will get notified on all the events that we will
So
check
we are
one by
using
one,
Epoll
right?
only, na?
Yeah, so that's why we are using Epoll, right? So shouldn't we not bother about configuring this event start from default value, like what is the maximum allowed, and then go one
No,
by
the
one, right?
problem is if suppose 1,000 events is notifying. So you will
Right.
get, if you are, suppose you have given max events as 2,000. So 1,000 will
Right.
come and you will
Right.
have to loop for the 1,000 times.
Yes.
Right. So what I want to do is I will just try to keep it to a minimum and try to handle those quickly and then go back again, is what I'm trying to say.
So I was thinking maybe if we have capacity to handle all those events, we should handle in one go, right? If we don't have capacity, then only we will try to optimize this max event parameter.
See what will happen. Think about this. So suppose 1,000 notifications came and you are listening for the max event is 1,000. It will return you 1,000 count, right? So what you will try to do is you will try to handle all the 1,000 inside this loop.
Right.
Right.
Yeah.
So what can happen is you will try to give it. So right now what code we'll write is we'll try to push the handling mechanism to the thread pool. Right. So instead of giving 1,000 to handle in the thread pool, what I'm trying to do is I'm giving small amount to the thread pool. Like first I'll take 10 and I'm giving it to the thread pool so that it will start doing its work till I come back again and I'll start getting the more notifications.
Okay. So
So
inherently,
that
this is
till
not
that time
limited by.
thread has started doing and started handling those handling other clients, right?
Okay. So it's just that we can write code to handle all the events, just that we are limited by the threadful implementation, how many threads it supports.
Because if you try to handle everything all at once, each client might become slow. Each client interaction might become slow.
Right. Okay.
Right. So you have to keep a balance between each client interaction, between and also between throughput. So throughput means each client I am having request per second high, but I am serving less number of clients. While other side could be I'm handling more number of clients, but each client throughput is less. So what do you want?
No, but
we
I don't quite agree, because ultimately everything is going to push on thread pool only. So that only will decide the outcome of the throughput. It's only that you are doing a one loop, or you are doing two for loops. Like that it looks to
I
me.
get it. But this is how it should be done. So
Okay.
if you read about it, max events, people tell generally 100 to 500 is a good idea to keep so that you don't
Okay.
give a very big number,
Okay.
right?
Yeah.
Amit, Epoll way cannot be made a non-blocking call.
It can be made a non-blocking call. If you give a 0 here, it will become a non-blocking. But what we are going to achieve right now with a non-blocking call? Because anyway, we are just listening for the events only, no?
Yeah. I
Right.
was
So it
thinking
makes
that we
sense to
can
wait.
declare a very large max events and
I think this could be a good thing to try and see if you are giving a big max event, does it hamper your system or does it make a good throughput? Right. But this is the theory in practice.
okay, yeah.
Yeah. Okay. So how we are going to check what events and how are we going to handle it? So this is how we'll handle it. So let's see. So what I'm doing is I am looping, and this particular events that is getting returned, I'm checking events of i.data.fd. Remember, I have put something while adding, I have put it in data.fd, the client socket. Remember? So I'll get the client socket from here. Events i.data.fd. Right? And I'll check what kind of event I have received for this particular FD. So event i.events and epoll. So I'm trying to end with epoll. So if it will return one if it is epoll, it will return one if it is epoll out, and if it will return one if it is epoll error, right? One of these three events, right? So if it is input, means I can receive, I am ready to receive. I am doing a thread poll push. And remember, this is the same code that we were doing. And then giving this handle receive. Inside this, we'll do a receive, actual receive. So similarly, handle send and handle error. Is this code clear? So we'll loop that many number of times till for that how many number of events notification we have got. And which event notification we have got, we are getting it through this. And on which event we are getting it through this. And then we are handling it by passing it this event FD. This passing it this FD. So on this, you have to do a receive. Here we will do a send, and here we'll do a handle error. Is this okay? So now Epoll is complete. You have created it, you have added it, and now you are getting the notifications.
Amit, what's the use of that int thread ID?
So yesterday we talked, no? So the thread pool that I will be using is this one.
Okay, it requires a thread ID.
It requires a thread ID.
Got it.
Yeah, so let me download also CTPL GitHub. Not this one, I think. CTPL, not this one. CTPL underscore STL.h. So this one I can download and put it in my source file, right? So that you can do. And now we were here. Okay. So now this is done. Only thing now required is this. We have to implement this handle receive, handle send, and handle error. Fine. So let's see what we'll do in these cases. So what we'll do in handle receive is, now this will be your business logic. So handle receive, we'll do the actual receive. So that till now we haven't done receive. Remember, we have nowhere written receive till now. So we'll do handle receive. We'll put this in our lin.h. It will still be, I think it will be a private only. We are keeping it private till now. And inside handle receive, what we'll do is okay. First this thing. Let me know if you understand this. So this is the same thing that we are doing yesterday for the receive, remember? So we can define our buffer size, whatever we want. So let's say buffer size is, let's say we are listening for 1024 array. Okay, so this is same what we were doing yesterday. We are doing a receive, actual receive. Now we are doing. Now how we have come here through our epoll. So epoll has said कि now on this particular socket, now you can receive. It is ready to be received. Some data has come. So if you do a receive now, right, you will get the data. You will get some data, right? But let's check for the error. What if if there is nothing there, right? So what can happen is we have to check for three conditions. If bytes read, if it is greater than 0, then we have actually received some data, right? The second condition is else if bytes read is equal to 0, right? What we'll do in this case? And else if it is negative, if bytes read is less than 0, right? Second condition. And if
But
bytes yeah,
second condition cannot arise. Otherwise, why would it give you notification?
Yeah,
it will arise when socket has been closed from the server side, from the client side.
Perfect.
Right. So in this case, you will do what? You can directly do a close socket, close and client socket, right?
Right. And what is -1?
Sorry, I didn't get this point.
What? So we were
no, I
talking
didn't get
yesterday.
This point. I mean, why? Because yeah, I mean, we've been notified that there is data in the receive buffer, and we've come here. So I mean, I still don't see the point. I still can't see through why we need that second else if condition at all. Like,
okay, so there could be a chance that while you are reading it, once you have read it, suppose you have read something and some data came, right?
Yeah.
And the next time what can happen is once we have read something, I will again go back into that epoll wala thing, right?
Right.
Some notification can come again, right? So while I'm reading it, it can happen that suppose they
I
are
mean, not for this socket, right? I mean, if the client has closed that socket off, the client closes the connection, then for this socket we won't get a notification, right?
Epoll should not give the notification, but we do as a code we should handle everything
for completeness.
For the completeness, yes.
Okay.
If even though I have got the notification, but have I read something or have I not? You have to check everything. You have to check all the errors, right?
Yeah.
So
and
what can happen?
For what? -1.
And yeah. So in else condition, when we'll come, we'll have a it means we are coming as a minus, right? So we have to check two things. We have to check whether there is something called error number. This thing. So this is some global variable per thread.
Got it.
Right? So its value could be like this. Let me show you. So this value could be this. So check this if condition. Either this or else this. So this is how you complete your full receive. This is, you should write like this, right? So, and also you are, once you have received something, it will go back in the epoll. Suppose you don't get to read anything. You tried, notification came, you tried to read, but suppose you read something, so nothing was there to be read, right? Till that time you came here, you received a notification, but you did not receive anything. Maybe there is some other thread also that you have operated on, then that would receive first. That could happen if you have not written properly. So when it came and did not see anything in the buffer, I have told you, right? Receive will automatically return if it did not receive anything, right? In that case, what it will give is, it will return -1 or negative number. If it has read something, it will be here. If the socket has closed, it will return 0. And if it does not read anything, it will quickly return. It won't block. In either of the case, this receive is not blocking is the point, which was happening earlier. So if it is not read anything, maybe later, some point later, some more data will come. So what I have to do is, there could be two things. Either there is some error because of -1, there is some error that has occurred on the socket. In that case, you should close the socket. Sorry, not here. So error number, if it is not E would block or not E again. So in that case, error has occurred. But if my error number is E would block or E again, in that case, I should just return. Now tell me.
Is it like spurious notification for the else case?
This one. Yeah, so this else case is for I have not read anything, so it is returning -1. So if it is -1, it has come inside. But this error number will be set to E would block or E again in case there is nothing wrong with that, but there is no data in the receive buffer. I have not read anything, but there is nothing wrong. I should not close. I might receive data later. So in that case, you should just return, because anyway, my socket is added in the Epoll, right? I will receive the notification again. If I receive the notification again, I'll just again come back to the handle receive and do a receive again.
And this error number is a variable that is unique for each client socket?
Unique for each thread.
Okay.
This is
thread local.
Each thread, yeah. So this will keep getting changed depending on what API you're using. So in each thread, if you are using receive or send, so this error number is a global variable for each thread, not process, each thread.
Yeah, got it. Thread local.
Yeah, thread local, correct. So this is how you'll write your receive.
But the notification would only come when the buffer has some data in it, right?
Yeah, correct. You are saying correct. Notification has come, but that till the time it has come and try to read it. So notification has come for the buffer to read, but you should always check whether if once you have read, is there something actually you have read or not. So it might happen in the socket code and all. You should always check for the return type.
Okay.
Right. So there could be three things, either 0, greater than 0 or less than 0. In less than 0, there could be two cases. Either error number is E would block or E again, or whether it is not. So if it is not, it means there is some error with the socket and you should close the socket. And if their error number is set to E would block or E again, you should, in that case, you should just return. Thinking that when the buffer will come, I will come back to this handle receive again and do a receive again.
Amit, will we also call this function recursively, like when bytes thread is greater than 0, to handle that case where there is more data in the buffer than what is our current buffer size?
Correct. We can do that.
And
so
in that
what
case,
he's
maybe
saying
you
is,
can get into this E would block.
What we can do it like this.
Either while one, or you can recursively
saying,
call
right?
it also.
Sorry?
Either while loop, or you can recursively call handle receive again from bytes thread is greater than 0, do the reading, and you can call handle receive again.
What you are saying is, if it is greater than 0, you are calling handle receive again.
After reading the data, yes.
But
Just to
then
make
again,
sure
you
that
have
there is no
to,
extra data left. Otherwise, we will have a server which may miss some data.
You are right, but then again, if you call it directly from here, then there will be a problem. If you
What
call it from
problem?
here, see, suppose you have some string. You have kept a string, data received, suppose. Earlier, it doesn't have anything, right? So the moment I keep on receiving, what I will do is I'll keep on doing append in this string, right? So this buffer. This buffer and how many buffer that I have received.
Okay.
Right.
Okay.
So now what you are telling is you call this function again, recursive. If it calls receive again, it is a new string again, right? And then there's separate. I want to combine everything in one string, right? The whole data. Right.
Okay.
So it makes sense you do inside a while loop.
Okay.
And there's also a problem if we do the while loop, right? I mean, the buffer size that we have set is 1024 bytes. And since it's a continuous array, we might end up reading the other client's data. That might also happen.
No. Each client has their own buffer,
Okay.
right? So
I'm
this,
talking in terms of the kernel buffer because
so kernel buffer also. Each socket will be associated with their own buffers.
okay.
No, there is no combined buffer or anything. Whenever you create a socket, there is a separate buffer that is allocated for that particular socket.
Okay.
Right. So
Amit,
there will be no overlapping of the buffers.
Okay.
Right.
Amit, sorry, I didn't follow this particular like the nuance that I think you guys are talking about. So if the buffer size is 1024 and you have received, and the kernel buffer is currently holding 4 KB of data,
yes,
then what do you do?
So what you can do is you can do it like this. You can put it inside a while one and you put this in receive call inside this while one.
Okay, yeah,
Right.
okay.
And then every time you read, the next time you read is like every time you read, you can do this. You can keep appending it
Okay. Until bytes
you
read
have received
equal
all the
to,
data.
yeah, 0 or
Right.
right? Yeah.
Yeah, you can keep on receiving until you have received 0 or a socket has closed. Or if there is no buffer, then you can directly return. You can go back to the Epoll again, so that next time Epoll notification come, you'll do a receive again. So the thing is, you have to maintain that state that you have read this much and you have to read again. Right. So quick. Tell
Amit,
me.
yeah, Amit, is it like we are trying to like? Is it a good case of edge trigger? Like in edge trigger, we'll be notified only once, but we are able to read all the buffer that is.
Yes. Good case for edge triggered. So once I have edge triggered has given me some notification, I should make sure that I receive everything. Otherwise, I will not receive the notification again.
Yes, nice.
For the same buffer, right?
Thank you.
Yeah, correct. You are very correct.
Amit,
So
once you taking the example of 4 KB itself, once you have read the complete 4 KB, you would end up closing the socket, the lines of code that you have written in the
yes,
ladder.
this is a good question. The answer is as you are writing this server, you should know ki when my client and server communication happens. So suppose in HTTP protocol, what happens is as a server, I know ki when I will receive the how do I receive HTTP inside HTTP? How do I receive? I first receive headers, right? Inside header, I get a content length, right?
Yeah.
Inside content length, I know ki these many data in the body that will come.
Exactly.
And where the body start, /r, /n, /r, and then the content. So I know ki suppose in content length there is 30 bytes. So I know ki 30 bytes I have to read. I don't know after that. Even if it is same or no, I will just skip it. So as you are writing a server, you have to decide client and server what protocol you are using. So suppose as a protocol,
if it was
I might
HTTP, like you are saying, if it was HTTP, right, which is stateless, and once I have responded to that request, then there's no point in holding that socket, right?
Yeah, but you can also do it like this. No, you can keep it alive. There is also an option to keep it alive. But the only question he's asking is, till what time you know ki you have received all the data?
No, also in addition to that, you would not abruptly end up closing the client socket, right? I mean, there can be a scenarios where client has not initiated the close yet, but server ended up closing the socket, and again when it has to send a new data, it has to do a three-way handshake and then proceed again. But I would want a seamless, smooth on the client end, right? I mean, the transactions should happen in a seamless manner, not do a three-way handshake every time it has to send data. That was my question.
Yeah, correct. And in that case, if you have to do that, you actually say in HTTP, there is a header called keep alive.
Okay, I've come across keep alive. Yeah.
So when you send that header, now when you have sent that header, the server will know, okay, this header has come. It means after sending the response, I will not break the connection.
But how would you actually parse through the HTTPS, the header while we are actually writing the using the socket APIs here. I mean, is there any API to parse those headers?
I mean,
I
we
mean, you
have
get
to
it
write
as
the
plain
code. I mean,
text,
you
right?
get the data.
Oh, okay.
And you'll
Okay. Okay, it's just a plain text that we get, and
Yeah,
then
yeah,
yes,
yeah.
yes.
Plain text
Okay.
block.
HTTP is plain text only, no?
So we'll have to look for those
Yes,
headers.
correct. You have to exactly look for, okay, the first line should be HTTP, something like that. Then there should be a \r\n. Then the second line should start with the header. The header will always be in the form key : space value. Then \r\n. Those whole thing we have to parse.
I mean, okay. And the buffer that we get would also contain the complete payload along with the header details, right? I mean,
the payload, whatever the payload that you are getting, in content length, you have to mention what is the number size of that payload in the header.
Okay.
So
Based
through
on
that header, you will know ki I'm
Yeah.
expecting suppose 500 bytes. So I'll keep on reading till 500 bytes
Yes.
after the header.
Fair enough. Makes sense. Yeah. Okay. Thanks.
So we'll do this. We'll try to do this whole thing in the next class.
Amit, also here in the line number 103, you have written that in a while true, so it will continuously keep on running, right? So 103.
103.
Yeah. So that.
So I have not completed this. This thing is not completed. So this while loop should not be here. Closing. This should be somewhere here. And I should be keep on reading till I am done. So I'll keep on reading. Once I have not received anything, I'll directly go to this loop. Either it will be a close or I'll return it back to the Epoll. So the next time notification come, I again come back to this handle receive.
And again, just to close on, I mean, my understanding of in the Epoll loop function, the number of basically the max count that we have given in the Epoll weight should it be compliance with the number of threads that we have in the thread pool, because that would eventually give us the, I mean, when we are doing the profilation and trying to find the performance.
So that's what I said. Ki if you read about it on the internet, no, people talk about this max events and they say ki generally for a good throughput system, 100 to 500 is a good idea because many people has profiled it already.
But my question is, would it be not same as the number of threads that we have in the thread pool?
If you keep it just for that many numbers, suppose we have 8 threads and 8 you have created. So what you are saying is we'll only move it for the 8 numbers and we'll put it in the queue. That's what you're saying, right?
Yeah, because it would, let's say there are 9 events coming in the Epoll, okay, and you have kept the max number of events as just 8, and you have only 8 threads to process. Anyways, the 9th event has to wait until the thread becomes available
but
for it.
We are also assuming that whatever the thread that is doing the work till that time will be completed soon. It won't be like that's what if this thread handle receive has come, there will be no point where it will be a blocking, or either it is doing a receive, or if it doesn't do a receive, it will be come back again. So till that time, I'm expecting my thread to do this work pretty fast, like handle and this receive and send. Until that time, I'm expecting that all other functionalities that I have to handle that I already come into the queue. So it should not happen that while I have already done the task, my thread, the task is already not in the queue only.
Otherwise, it would again become like just using the thread pool without the epoll. Okay.
Getting my point. So I am expecting ki till the time my thread has already done the task, I am expecting 5-6 tasks is already there in the queue already. So that quickly my thread can pick it up. Because when I'm doing this non-blocking and epoll thing, I'm expecting not any particular thread is not being inside a particular function for a long period of time. So it will do a receive quickly and it will come back to epoll.
Okay.
There is no point, there is no way my code, any function is not there where it is actually getting blocked. Only thing you are getting two where it is getting blocked. One is epoll wait. Why it will be blocked? Because no event is there. So that's fine. I don't have to do any task. One is wait here and the other wait is here in accept call. And when it will be blocked, because no connection is coming, and I'm okay with that, because if no connection is coming, I'm okay being waiting here.
Okay.
Right.
Okay, thanks.
Otherwise, in no part of my code there is no thread that will be waiting at any particular point of time. All threads will be doing some work.
Okay, but the moment you make it as non-blocking, I'm thinking from the Redis protocol, the way it works. I mean, it works on a single-threaded manner. Would they also take the advantage of the kernel calls or the OS calls that we make?
They must be there. So if single thread, when they say single thread, they must be taking this event notification wala thing.
Okay. Okay. Yeah. Anyways, I'll have to go through their code
Yeah.
base to understand. But yeah. Okay. Thanks. Makes sense. I mean, yeah.
So I'll quickly write the send wala part, and then we'll quickly close this for today. So the send part will also remain quite similar. If you have understood handle receive, send part. So this handle send will do the actual send, and then we'll simply check for all the event, this error number and all, everything will check. Similar like this. So this code right now you can avoid. I've written code to maintain the state and all that you can. I'll tell you later, but it's the same thing. If I'm able to send, or if I'm not able to send, there will be two conditions. Either my error number is E again or E would block. In that case, I'll simply return. And if there is some other error, then I'm doing a handle error, which is inside handle error. I'm actually doing a close socket. That's it. Same. Handle receive and handle send. And inside there is one also called handle error, right? So in that simply I'm doing close socket. I would have tried to write all the code. But one thing I can do is, because it is already 4:17. Okay, the first thing is Epoll clear? Now is it clear in your head? Can you visualize what Epoll is doing? Now it should not seem to be a foreign concept now.
I mean, theoretically, it's understood, but I think probably at least I'll have to go and, read through once again to understand a bit more.
Yeah. I mean, not just read through, you should code at least once.
Yeah.
To actually get the feel of it.
Yeah.
Because even if you see it, unless you go and write it, you will try to understand, okay, why this is happening, why that is happening, and you'll actually see the code moving here and there. You should put a breakpoint and see how is it moving, right?
You had mentioned in the last session that Windows does not have an e-polling instance, right? So on Windows, probably you'll have to write some you will have to use some Windows specific functionality.
So on Windows, we'll use IOCP. I told yesterday.
IOCP, okay.
Yep. So what I'll do is two things. First of all, I'm sure not many of you have started with the client socket and code and all. So first, again, go through writing whatever we did yesterday. Then go start writing Epoll. The second thing is how we have creating our folder structure. No, we are creating TCP server, everything like we have created. Try to create that, but the way I have done, right? Make it usable, like how the actual user would have written for the production, right? Try to maintain the same kind of folder structure and try to replicate this. The thing which I will do it for your convenience and all is, I have written a lot of code already, which is like handling everything for client on the Windows side, also server side, also for the Linux and Windows, everything. So I'll put that everything. In fact, it is already there. I put it on GitHub so that you can use it and try to write your own. You just use it as a reference, right? So this code also I am only writing right now only. So it's not like it will be all error prone. It will not have any error and all. So don't take it for granted. But only thing is you can use it as a reference. Whatever we have studied and all, you can, and it is a running code right now. So if you go ahead and do a CMake build and everything, the code will run on Linux and Windows, everything. So you can even try that, right? I'll put it on this Discord. I'll put the link on Discord. You can go through the code. Meanwhile, from the next time, we'll discuss a little bit of whatever the code we have written. We'll try to create a new executable and try to use our library, this Linux, whatever server we are creating. We'll start with that, and then quickly we will move on to creating how we can create our own web server, right? So right now it is only TCP server. We are only sending simple data here and there. But next time we'll try to see how we can create a proper web server. Like it will serve HTTP requests and it will give HTTP response back, which is nothing but a simple, we have to check, we have to parse a lot of strings and all. That's it. That is the only difference that will happen.
It will be interesting to see, or after we are done, benchmark the performance of our server with some actual commercial one. And
I mean, please, I would really request at least few of you at least try who are active. It will be a very good thing to actually see if we can write a better server than what is available on the market, right? Because we are actually using those concepts, which actually is a production grade. Because in production, these are the concept that is used to create a production grade servers, right? So the next we'll be doing a web server, and if time permits, we'll also see IO_uring, the API that, right? So that is a very important concept. So what is happening in Epoll is right now, if you see, it is just a event notification mechanism. So Epoll just tells you that now you are ready to do a read or write, right? But using IO_uring, it is actually async. Like you tell you do a receive. Will not do a receive. You do a receive on this socket. Once the receive is done, you tell me. That's it. Understand the difference? Epoll is just telling me you do a receive. Now you can do a receive. IO_uring will do the receive for us and then tell I have done the receive. Right? So that still make it more faster than Epoll.
IO_uring is a kernel level facility or it's an API?
So IO_uring is similar to Epoll. What Epoll API is there, no? IO_uring is an API that we can use, right? And there are some concepts that we'll discuss when we'll discuss IO_uring. But before that, please try to do this. Otherwise, I don't know how much code I can actually write in the class and also go to the theory, right? So if you have understood the theory, you please try to write the code yourself. Because I am not seeing any activity on Discord now. Right. And this code, and one more homework I want to give for this week so that you are also like engaged in doing that. So homework will be, I think many has left, but I'll put the homework in the Discord also. So the homework, I'll put it in one line. So homework will be, you have to create your own, what do you call, like SSH server and client, right? So how do you connect to a different remote system and then execute the commands, right? And you see it on your system. So like you give a command, right? You see a directory or you change the directory, everything you copy from the remote file and copy it to your local file. That you have to do using this server and client. So you have to write your own.
What SSH is I know SSH is doing something secure, but it is the protocol for basically executing remote commands securely, is it, or what?
Yeah.
Okay.
So what we are doing here, no, like we are using this VS Code right now. So this is nothing but SSH only, no? This one.
Okay.
Right. So if I go here and inside terminal, if I see ls, there is no folder inside this. So if I see ls, I can see the networking folder, right? But this is on the remote. So similar, you'll have to create a separate server which will be residing on the remote server, and then you will have to write your own client that will be on your system, and you have to connect that, and then you have to send the commands to go in towards the remote side, and whatever the result of that command, you have to show it on your console.
Okay.
Getting the point? And it will be very interesting thing.
Yeah.
Right? And it's very very simple to do also now that you have understood the concept. Like you will take a input, like suppose I take a input, like suppose ls. You will give this ls to the server side. On server side, you will take the ls, and there is API called popen on Linux. You will put that command inside popen. It will give you the result of that, and you'll push that result back to the client. That's it. So let's see if anyone can do it, right? Meanwhile, I'll keep writing the web server, and so that I can show you a proper web server on the next class. So let's pack it up for today. Fine. No question,
Super
right?
interesting session. Thanks a lot.
Yeah, I hope it is interesting because these are very good concepts. Like this is not only important for the socket point of view, you can use this concept for any input and output mechanism. You can use this for making the file throughput also, like you are reading from the file, outputting for the file. That also could be have a good throughput if you're using these concepts, right? So, okay. So let's meet next week. Fine. Bye.
Yeah, thanks, Amit. It was good.
Yeah.
Today.
Bye.
Yeah.
But please try to do the homework, and whatever it is, let's discuss on Discord.
Sure. Yeah.
Yeah. Fine. Bye-bye.
Bye.
Bye.